Hello guys and welcome to AI Sciences. Today we are going to build a stock price prediction model and we will do some stock price predictions by using LSTM model. Agenda is the following. We'll start by data loading, then we'll do some data pre-processing, then we'll build an LSTM model, and finally we'll do some testing and results will be visualized. My name is Sajjad Mustafa. I am instructor at AI Sciences. We make tutorials and complete courses for students who are beginners in artificial intelligence. So if you want to start your career in artificial intelligence, check the link below. Now, what is a stock price prediction? And you might be wondering that we should learn some basics of it. If you want to learn some basics of it, check out the link in description. We have just released an animated video in which we have explained what is a stock price prediction. So in this video, we are going to do some hands-on practice by using Python, and we're going to build a complete project on stock price prediction. So let's go. So here we have a Google Colab. So Google Colab is those people who are new to Google Colab. It's just a Jupyter notebook, and it is available if you have a Google account. If you're working with Google Colab, you don't need to install any libraries in your local system, right? So you can install libraries on a server, right? So here are some imports that we have to do. We are importing pandas, we are importing NumPy, then matplotlib for some data visualizations, right? And then from sklearn pre-processing model, we're going to import min-max scaler for data pre-processing, obviously. And then we are going to import a sequential model from Keras, and then some LSTM dropout and dense layer. Okay, so now details of these things will be explained wherever we will use these things, right? So first of all, let's just import them, and it will take a few seconds. Meanwhile, let me tell you what is this. So from Google Colab, we are importing files. What is this file? Now I want to upload a data file in which I'll be having a training data, some training data, right? Now where is our training data? Let's see. Here is the training data. Okay, so this file is in my local system, so I will upload this file to the Google Colab. So here in this training data, I have some dates, some missing values in dates as well. I have dates, opening, high, low, last, and closing rates, and we are going to predict only closing rates, right? So you can later on build your model for opening rates as well. So here, let's run this cell. By the way, this cell has run successfully. So let's run this cell, and here you can see that it is giving me options to choose the file. So I am going to choose the file, and it will allow me to choose the file from my local system. Here you can see that this is the directory of my local system. So here is my data file, a CSV file. So I am going to upload this file. So this file will be available. Here you can see that this file is now available on Google Colab for me temporarily. Okay, so here I'll say let's explore this file first on Google Colab. So I'll say data frame or df equals to pd. Now what is pd? Pd is this pandas, right? So I'll say not dp but pd dot read csv. I want to read underscore csv. Here is auto completion. By the way, in Google Colab, if you want to do auto completion, you can just press Control Enter if you have a laptop, and if you have a Macintosh system, you can press you can press Control and space. So here in this CSV, I'll pass the name of this file. I'll copy it from here and I'll paste it over here, right? So here I'll say data frame dot head, show me the initial lines or initial records of the data frame. Here you can see that, right? So we are perfect over here, and then over here we are just going to say data frame, sorry, here we'll say data frame date, and in this thing we are going to say pd dot to date time underscore date time, and here we are going to pass we are going to say data frame dot date. Here we mean this column, so, right? So dot date we just want to make it in one format, in just in case if there's a format missing or something. So we'll say here we'll do something like percentage, and then first of all show year, and then show percentage month, and then show percentage day, right? Perfect. And then we'll say make it the index column, df dot index, and in index we'll say data frame, and here we'll say date. Perfect. And now we are going to, let's say we are going to plot, let's do some data visualization now. So let's plot this closing rate. Oh, I've missed this. So let's plot this closing rate, this closing rate with respect to date. So here we can do PLT. By the way, PLT is coming from this matplotlib, right? This PLT, and here we're going to write PLT dot. Let's make a figure first, and in this figure we're going to say fig size, and fig size is we're going to pass a tuple, and here we'll say 10 units on x-axis and 5 units on y-axis, and then we'll say PLT dot plot, and here we'll say data frame, and in this we'll say close, right? And let's run it. Ta-da! Here you can see that. So it has plotted the closing rates with respect to date. You might be wondering that we haven't passed the date here. We haven't passed the date to as parameters, right? Because since we had made date as an index column, so we don't have to pass an index. It will automatically consider that this index column is going to be on x-axis. So here you can see that this is the stock price prediction of the data that we already have, and if you want to find this file, I'll also you can also find the link in the description if you want to download this file, or if you want to have this notebook as the coding of this notebook, you can find it in the description, right? So we have visualized the data, we have loaded the data. Now next thing is we want to do some data pre-processing, right? So let's do some data pre-processing. So here I'll say data, and let's sort the data first on the basis of date. So I'll say data frame dot sort index. Now what is index? I hope you know that our date is the index column, and we'll sort it in ascending order. I'll say true, and I'll say access should be, let's make access equals to 0. Okay, and now I'll say new that's a new data set, right? New data set equals to pd pandas dot, we are going to make a new data frame, right? So pandas pd dot data frame, and here we are going to do something like index will be equals to range from 0 to the length of data frame, right? df, and then here its columns would be what would be the columns? Let's pass a list of columns. So we merely need 2 columns, a date, and what else? We need a closing rate. So here is the closing rate. Perfect. Awesome. And now we will populate this new data set. So I will say for let's say I in range. Before that let me write range. Before that, let's say how many days of prediction do you want to use. So let's say I'll say days equals to, let's say 60. I want to make use of 60 days for the prediction. So I'll say for I in range 0 to length of data. Okay, and then let's populate our new data set, right? And here we'll say it, here we'll say date, D is capital, sorry, date of I equals to from data, and same thing, we want to paste it over there, copy, paste, and same goes out for the closing rate. We just have to change it over here, right? Perfect. And also over here. Now, awesome. Now our new data set is almost ready, and what we want to do is we will say new data set, right, dot index equals to again we want to set its index, so new data set dot date column will be the index, and sorry, date. Perfect. And then again we want to drop this old column that we have as date, because now we have date as our index column. So we'll say drop what, drop date, and drop it as column. So I'll say x is equals to, guess what, 1, and then in place true. So we want to make change in our original data set, right? Perfect. We have populated our data set, our new data set. And now we have made the date column as index, and the original date column is being dropped. Now our final data set, let's say final data set should be equals to, you can make changes in this one as well, but just to be clear, I'm making a new variable, so this will be equals to new data set. I was waiting for auto completion, but yeah, so dataset dot values. Awesome. Now we want to make a train test split, right? So usually people send 70 or 80% data to training, and 20 to 30% data for testing or validation set. So I'll say train data equals to final, it's taking time, so I'll just write it, final data set. So in this data set we actually have how many rows? Let me see. Okay, so let's go to our Excel sheet and let's see how many rows do we have. So it has 1236 rows. So roughly I'll say for training set I'll be having from 0 to 987 records, right, and all the rows, and sorry, all the columns. And then for validation set we'll have remaining columns. Awesome. And here we'll say from 987 to onwards, and then here we'll also see all the columns. Perfect. Now we have our training and testing set. Now it's time to do some data pre-processing. So we will say let's make a min-max instance. So we'll say min-max scalar. Perfect. Here we'll pass, let's say feature range is, we have to pass a tuple from 0 to 1. So it will compress all the closing rates from 0 to 1. It will compress them in a way that we will be able to decompress them later on as well. So I'll say scaled data, or you can say pre-processed data, is scalar dot fit transform, and here we'll say, okay, do it on our final data set. Perfect. So now we have our train test split. We have done some data pre-processing as well. So Now let's split our data as XY, or in other words as label column and training column. So label column and feature column. So we'll say X train underscore data and Y train underscore data equals to empty. Why? Because we are going to populate them over here. So for I in range, here we'll say from days. Now what is days? Days are a variable over here. I mean, as I explained, how many days do you want to use in order to make predictions? So days, and then length of data, right? No, actually we should say length of train data. Perfect. And here we'll say X train, sorry. Now actually we have to populate these two variables, so let me copy them and paste them over here. Something like this. Okay, so here we'll say let's yeah, here is a spelling mistake, TRAIN. Yeah, perfect. So it was looking weird, that's why I stopped. So here we'll say dot append, and what do we want to append in it? So we'll say scaled data, right? Scaled data. And what indexes of this data do we want to use? So we'll say I minus days from this to I, and our dimensions would be this, and same, not same but almost same goes out for this as well. So here we'll say scaled data, and here let's pass I, and dimensions would be again 0. Perfect. So now we have our feature and label split as well. So now let's convert our data into NumPy arrays so that we can feed it directly to our network. So we'll say X train and Y train, let's just copy them, and here we'll say NumPy. Remember NP? NP is NumPy that we have imported above. So let me add some. Okay, so NumPy dot sorry, NumPy dot array, and here we'll say X train data, and again we'll do same thing for Y train data, but this thing would be changed. Okay, so now we have our data in the form of NumPy arrays. The next step is to reshape the data. So we'll say X train. Now question is, why are we going to reshape the data? Because the sequential model accepts the data in a certain format, so that's why we are going to reshape it, right? So NumPy dot reshape, yeah, exactly, reshape that I want to do. They are suggesting me for auto correction, right? So this is what I want to do. And now, so here we are going to pass X underscore train data, and here we are going to pass a tuple in which we will tell them the dimension. So X underscore train data dot shape 0, right? Shape tells us the dimension of data, so we are going to pick the number of rows, and then X underscore train data dot shape, and here we are going to get the number of columns. We could have done some hard coding, but that is the worst thing to do. Okay, so we have done a lot of things in this cell. Let me just do a little bit of recap. So we had imported the data, and then we made a new data set. We populated this new data set with the old data in a new format, and then we did some train test split. We did some scaling of data. In other words, we did some pre-processing of data, and here we are going to reshape the data, and let's run it and see if there is any error or not. Yeah, as I was expecting, there must be some um, yeah, spelling mistake. So this should have been done. Okay, because I copied this data from here to here, and I made a correction over here, but originally it wasn't correct. So now it is an error-free cell. Let's proceed, and our next goal is to build an LSTM model. So I'll say LSTM, right? So let's say LSTM model is, oh no, not LSTM plus, but LSTM underscore. So LSTM model equals to sequential. Now where is this sequential coming from? Think about it. Until you should think about it. Until then I'll write the rest of the code. Right? No, it's not right. I should explain it first. So what is this sequential? Sequential is coming from an import that we did over here. So sequential is sequential is an instance of Keras models. So by using this sequential thing, we can build layers of LSTM or layers of neural network in any format that we want. So we'll say LSTM model dot. So here we are going to add a layer. So I'll say LSTM. Now what is this LSTM? Again, we have imported this in our very first cell. So LSTM, I'll say give me let's say give me 50 units, right? Now remember, these are the hyperparameters that you can play around with, right? And I'll say return sequences. Yeah, I need this true because I need a feed backward network as well. And then I'll say input shape input, yeah, right, as input shape equals to, here we have to pass a tuple in which we'll explain the shape x underscore train data, yeah, train data dot shape, and we need the columns of it, and then again appending one just for the sake of format. Okay, so our layer is ready, and it's not complete. Layer is ready, but model is not ready, so because we have to add another layer, LSTM model dot add. Let's do some dropout thing. Let's set our dropout rate equals to let's say 0.2. okay, and let's just replicate this thing. Again, you can play around with the number of layers, with the number of units. We don't have to do this again, so let's just remove it. Great, we have 50 units again, and then dropout is again 0.2, and the last but not the least thing is LSTM model dot add. Guess what are we going to add? We are going to add a dense layer, so that because our prediction is going to be 1 unit, is going to be a 1 number, so in dense layer we are going to just add one unit. So our model structure is ready. Now let's do some model training, for which we have created the model. So LSTM model dot compile, here we'll say loss equals to what should be the loss function? Let's use the most frequent one. You can change this function according to your need. So I'm going to use mean squared error. Mean squared no, it was underscore error, right? And what optimizer I'm going to use? Optimizer. What do you want me to use? Let's use Adam. I didn't hear whatever you said, so it doesn't matter. I'm sorry. Okay, so LSTM underscore model dot fit. Let's fit this model now. In other words, let's ask this model to train itself. So I'll say x train data, then y train data, and then how many epochs for which we want to run it. Let's make it 4 for now. You can again, this is another hyperparameter. You can change it according to your need, and my batch size would be, let's say, 16, and verbose, let's make it 2. Now what is verbose, by the way? This is it has nothing to do with the model. It will just show how model is running. In other words, it will show the number of epochs. So if value of verbose would be 0, it will show nothing. If value of verbose would be 1, it will show a line, and if value of verbose would be 2, it will show the number of epochs it has completed yet, right? So let's ask this data to this model to train itself. So we have a syntax error. What sort of syntax error here in dropout? Okay. So I think we missed a bracket over here. Looks fine. Again, another error, and what it says. It says, let me see what this error says. Okay, it says that we have some issue with one of these things. Let's explore it. Oh, again, as I expected, there is a spelling mistake. So there's nothing like white train data. It was like white tain data. So I have to run it again. Data is ready. Now let's train our model, and you can see that, as I told you, verbose equals to 2 makes some visibility of how epochs are being trained. So you can see that in first epochs the loss was 0.0039, and then loss in next epoch loss decreased, in next epochs loss even decreased, and so on. You can change the number of epochs and play around it, right? So now our LSTM model is ready. Now it's time to do the next step, which is testing the data and visualizing the data. So I have already written the code for this thing for you guys, and I'm not going to write the code live. So here's the code. I'm going to explain this code for you because most of the technical things we are done. So here's the code. Okay, so here is the code for testing and data visualization. So let's prepare our data for testing. Okay, so input data equals to new data set, right? And we are going to get these values out of it. 60, remember what is 60? 60 is the number of days. So let's not hard code it. Then we are going to reshape the data, and again we are going to transform the data, right? And here what we are going to do is we are going to prepare our data for testing. Again, a loop just like before. Let's replace 60 with days. I was doing some experiments, so so again, this loop, what is this loop doing? This loop is doing exactly same thing which loop was doing. Let's find it out. What this loop was doing, right? So, and then we are going to convert it into a NumPy array. Then we are going to reshape the data. These are the same steps that we have done for our training data, right? So finally, we are going to use Lstmodel.predict. This is an important line. So here it is going to predict the data. How is it is going to predict the data? Because LSTM model, we have trained this LSTM model over here. You can see that LSTModel.fit, right? So Lstmodel.predict will actually predict the data upon will predict X test data, right? Now what is X test? You remember we have done this train test split somewhere over here. You can see that validation. It is coming from this validation data, right? So let's come back over here. So here this will get us a closing price, which was our goal. And then one thing, you remember that we have done some data pre-processing. Now we have to transform back our data. Here we are transforming our data, and now we have to do some inverse transformation, so that let's say there was a closing price of $1,000, before this line, before transformation of data. After transformation it becomes 0.64, let's say. And now we have we again want to get the inverse transformation of the data, so that this 0.64 again becomes $1,000, right? And then we are saving our data if we want to use this data for future, or we don't want to train again the data, so this line would be used for that. And then here train data, here we are going to plot our data, right? So let me first comment out this line and show you how our training data looks like. We have already shown you that, and let's show it. Let me show it to you again. So here you can see that this is how our training data looks like. And after predictions, let's now let's let me remove this comment. Now it will also plot the validation data in another color. You will see the difference. You will see here, you can see that. So this green line, actually, you remember that we have splitted our train test data into like 80-20 split, 80% and 20% split. So this 80% data, this blue data, is our training data, right? And this green data is the actual data, and sorry, this orange data is our actual data, and this green line is the prediction line, and it is not doing quite bad. By the way, here is a disclaimer. This is not a business advice, or this is not a model that you should use for your business. This is just a programming advice or a programming language. So again, this model is not very bad. It is not doing very bad predictions, although there are some differences, but it is not doing very bad predictions. Point to learn is here are some parameters that you can change, or perhaps you should change, in order to see how better your predictions are going. I have added 50 units. You can add 30 or perhaps 80 or 100 units. I have used 0.2 as a drop rate. You can use 0.3 or 0.1 as well. And then you can use another loss function. However, you can use another optimizer as well, batch size, number of epochs. These all are the hyperparameters that you should play around with. So guys, that's all about my side. We have successfully built a stock price prediction model, and hope to see you next week. Bye.